8.6 sketching planes in R cubed. So a sketchable plane in R cubed can be created by using a combination of points and lines that help define that plane. Okay, so to sketch the graph of a plane, we must consider each of the following cases as it relates to the Cartesian equation, okay? So there's going to be three cases. I'm not going to go through them all thoroughly at first. What I'm going to do is just like embed these boxes into the actual questions. Okay, but I'll just go over case one is when the equation contains one variable. So either an x, a y, or a z. See, x, y, or z. Okay, case two is when the equation contains two variables. So for example, xy or yz or xz. Okay, or the same situation over here. And then I'll flip the screen. Okay, or if the equation contains three variables, so the entire thing x, y, and z. Okay, or x, y, and z. Okay, and just note that all of the cases on the left, d equals 0, so there's basically no d. And all the equations on the right, d actually has a value, so there is a d. Well, a value that's not 0. Okay, so let's go ahead and just like start these. Let's take a look and then we'll embed all the situations right into the questions. Okay, example 1, we're going to draw the planes with these equations right here. So we have plane 1, x equals 5, plane 2, y equals 6, plane 3, z equals 6. So if we think about these, all of these have only one variable in them, okay? So it's definitely case 1. And then we have to decide whether or not the d value equals 0. Okay, so if we took x equals 5, what we have to do is we have to actually write that into Cartesian form. X minus 5 equals 0. So we have an x value and we have a d value. Okay, so I'm going to just paste the situation at the bottom. Okay, so this is case 1. So I'll go over case 1 now. The equation contains one variable. So if the equation only contains one variable, that means 2 of either a, b, or c equals 0 and d equals 0, then what we're actually talking about are coordinate planes, and that's what we're going to draw. However, in these three cases, you can tell that the d does not equal 0, so this is our situation here. Okay, we have one variable and we have a d value. So these equations, these planes are parallel to the coordinate planes. Okay, I'm going to go ahead and just quickly rearrange these. So y minus 6 equals 0 is another one of our equations in Cartesian form. X equals 6 or z equals 6, bring that over. Z minus 6 equals 0. Okay, so here are the three planes. Let's write a little description of them. Yeah, I'm going to change this a little bit. We're not going to write generalization. We're actually just going to sketch it right here. Okay, so description. So x equals 5. This goes through the point, 5, 0, 0. Okay, so x is 0, y is 0. And this is parallel to the, because it contains like that x, it's parallel to the YZ plane. So let's go ahead and sketch that. So the sketch, you probably have way more room on your paper, so I'm going to sketch it right over here. Okay, so when we sketch, we always want to draw x, then y, then z. So if we think about the YZ plane, we think about like this wall here, and I'm going to put dots on it. We think about that wall. So let's sketch a point that goes through the x-axis at 5. Let's call this 5. Okay, and then what's going to happen is our plane is going to be parallel to that ZY plane. And remember, our planes extend in all directions forever and ever. So this is going to be our plane. And it's going to extend left and right and then up and down forever. If we talk about y equals 6, we know that y equals 6 goes to the point, like the y-intercept. This goes through the point 0, 6, 0. Okay, and this is parallel to the, since it contains y, it's parallel to the xz plane. Okay, so if we sketch this on the side, and I'm going to sketch this actually pretty big in here, x, y, and z. Okay, if we think about what the xz plane looks like, so x and z is right here, so x and z is this plane right here. Okay, so if our point goes through 6, then what our plane would look like is, it would look like that xz plane, and we only have to draw a parallelogram, remember? Okay, that is our plane right there. Or, sorry, our plane. Okay, and then for z equals 6, we know that this goes through the point 0, 0, 6, and it's parallel to the xy plane. Okay, so let's draw x, y, z again. X, y, z. The xy plane is right here. Okay, this is x, this is y, and this is the xy plane, right? It doesn't go up or down. There's no z component. So now, if we draw this plane but up 6 units, it's going to be in the air. So now that is our plane. Okay, example 2. Sketch the plane defined by the equation 2x minus y equals 0. So if we think about this, we have 2 variables, okay? And then we don't have to carry anything over. So our situation is 2 variables and d equals 0 because we don't have that d value. So let's go ahead and copy and paste our box. So here's the case. The equation contains 2 variables. Okay, we know that d equals 0, so we're actually going to talk about this first option right here. So one of the coefficients, a, b, or c, equals 0, and d equals 0. What we're going to do is we're going to find a point, and then we're going to join the point to the origin and draw a plane containing the missing variable and this point. Okay, so first our missing variable is z. Okay, and I'm going to just draw a plane here, x, y, and z. So I just want to point out, because our d equals 0, what we can do is if we subbed in 0 for x, 0 for y, then 0 equals 0, that works. So we know that our point goes through the origin. Okay, whenever d equals 0, I believe that our point goes through the origin. Okay, so our plane goes through the origin. Okay, so now let's just sub in a number for, let's sub in like y equals 2. Okay, and what we're going to do is we're going to isolate for x, and then we're going to have an equation or a point on the line. Okay, and remember, every single point here, the z is going to equal 0. So we actually only need to solve for one variable here. So we're going to sub in just a random point, y equals 2. We're going to go 2x minus 2 equals 0. Bring that over. 2x equals 2, x equals 1. Okay, so now we have some point that lies on this plane. So 1, 2, 0. So it goes 1 in the x direction, 2 in the y direction. Okay. So our plane is going to contain the axis, the missing variable axis, so z. And it's going to go through the origin, and then it's going to contain the point that we found. And this here is the plane 2x minus y equals 0. Okay, so find a point, join the point in the origin, and then draw the plane containing the missing variable. So the missing variable z contains the z-axis. Asks us to write descriptions of plane 1 here and plane 2. Okay, so here we have in both these situations, we have two variables. Okay, and in both situations, d equals 0. So let's deal with plane 1 first. We have 2x minus z equals 0. Okay, so we know that we're missing the z. So we are going to contain the z-axis. We know that we're going to go through the origin. Okay, and then all we'd have to do is find a point that we could also go through. Okay, and that's really it for that one. Okay, so for plane 2, we have y plus 2z equals 0. So we're missing the x value. So that means that we're going to contain the x-axis, and we're going to go through the origin. Okay, so I just want to point out, see this 2x minus z equals 0. So our plane will cut the xz plane along this line, along the line 2x minus z equals 0. Okay, see how we have x and z? Well, we're not gonna, this plane's not gonna lie on the x plane or parallel to the x plane or the z plane, but it's gonna cut the xz plane along that line. Okay, likewise, plane 2, we have y and z. So our plane will cut the YZ plane along the line y plus 2z equals 0. And that's it. There's a description of these two planes and how they look. Example 4, sketch the plane defined by this equation. 2x minus 5y minus 10 equals 0. Okay, so what part are we missing? We're missing missing z. Okay, so we know that our plane is going to be parallel to the z-axis. And the easiest way to sketch the plane defined by two variables here is to find, like in this case, the x and y intercepts. Okay, so in order to find the x-intercept, what we have to do is we have to sub 0 in for y and z and then solve. So 2x minus 5, 0 minus 10 equals 0. Okay, that just goes away. 2x equals 10, we get x equals 5. So our x-intercept is 5, 0, 0. Okay, we're going to do the same thing for the y-intercept. Y-intercept, so it's going to be 0, some number y that we're going to solve for, 0. Okay, 2, 0 minus 5y minus 10 equals 0. Well, anything times 0 is just 0, so then we have negative 5y equals 10, and we get y equals negative 2. Okay, so our y-intercept is 0, negative 2, 0. Okay, so if we were to draw this, what we want to do is we want to draw the plane that goes through x 5, 0, 0. So let's call this 5. So our plane is going to go through here. And then also y equals negative 2. So the three axes that we draw here are positive. So y equals negative 2 is going to be somewhere here. Okay, negative 2. So now all we do is we connect this, and then we make our plane parallel to that z-axis. Let me put this more on an angle. Okay, so 5, and let's go -2's here. So straight up from 5, and then connect to -2, and then this is what our plane is going to look like. And if we're looking for direction vectors of this plane, what we want to do is we can find direction vectors by subtracting these 2 points. So 5, 0, 0, 0, -2, 0. So 5 minus 0, 0 minus -2, 0 minus 0. Okay, so one direction vector is going to be 5, 2, 0. Okay, and the other direction vector, well, we know that when we dot 2x minus 5y, I'm not even going to write the whole thing out, 2, -5, 0. When we dot that with some point x, y, z, we need to get 0, right, in order for it to be a direction vector, because 2, -5, 0 is our normal. So we can do 2x minus 5y plus, well, 0z is just 0. So let's just put equals 0. Okay. We need to get 2x, 5y equals 0. We can actually use the direction vector 0, because 2 times 0 minus 0 equals 0. So we can use the direction vector 0, 0, and then for that z value, we can actually sub in any number for it. Since if we put like plus 0z, we can sub any number in for that z, and it will still equal 0. Okay, so 0, 0, 0, that would be like another direction vector. Let's call that direction vector number 2. Just if you need to expand and go a little bit, a couple steps further. Example 5, sketch this plane. So plane 1, x plus 3y minus z equals 0. Okay, so as soon as I see this, I think to myself, there's an x, a y, a z, but the d is going to equal 0. So if I were to look at that chart, let's just paste the chart here at the bottom. Okay, if I were to look at this chart, I know that d equals 0. Our equation is in this form right here. Some x, some y, some z, and then equals 0. So what we're going to do is we're going to determine 2 points in addition to 0, 0, 0. So we know that this, because d equals 0, this plane goes through the origin. Okay, and then what we're going to do is we're going to draw the plane through these points. Okay, so this is a little bit more difficult than what we just saw, because usually we would just find the x, y, and z intercepts and then plot those and graph the plane. However, the x, y, and z intercepts are all the same. They all go through the origin, which is 0, 0, 0. In this case, what we want to do is we want to find a point that intercepts the x, y plane. Okay, and then also the xz plane. Okay, so in order to intercept the xy plane, z has to equal 0, which is no problem. We just take x plus 3y minus 0 equals 0. Okay, so let's just simplify this and just rewrite it as x plus 3y equals 0. So we've seen this before. The xy plane is intercepted along the line x plus 3y equals 0. So all we have to do is we have to find a point that satisfies this equation, okay? So the easiest way to do this is think of like the negative reciprocal for slope, like b over a, right? Instead of writing like the coefficient 1 and then 3, I would flip them. So I would do -3 and then 1. Okay, so for example, 1 times -3 is -3, plus 3 times 1 is 3. So -3 plus 3 is 0. Okay, and then we subbed in z equals 0. So -3, 1, 0 is a point on our plane. We're going to do the same thing for the xz plane. In this case, y equals 0. So x plus 3y minus z equals 0. Okay, this just goes away. X minus z equals 0. And now we need to find a point that satisfies this. So we know that we subbed in 0 for y. So we have the coefficients here are 1 and -1. So we can simply just sub in 1 and 1 because these are opposite signs. So like 1x, so 1 minus 1 equals 0. Okay, so the point 1, 0, 1 works as well. Okay, so now let's actually plot. Okay, we draw the x, y, and z axis. X is always popping out at us, y is always to the right, and z is always vertical. Okay, now simply let's plot these points. Oh, okay, so 0, 0, 0, and then we have -3, 1, 0. So -3, 1, 0. And then 1, 0, 1. So 1, 0, and then 1 up. Okay, so we can draw this plane represented by this triangle, and this triangle is just a cutout of the plane. Okay, so remember, if it goes through the origin, then we have to substitute 0 in for one of either x, y, or z, and then kind of like trial and error almost the other two variables. Okay, however, if it doesn't go through the origin, we can just find the x, y, and z intercepts. Okay, by subbing in 0, 0 for y and z, or 0 for x and z, or 0, 0, and then finding z. Okay, so that would be the three intercepts. So that's the only difference between if we have a d or if d equals 0. Example 6, sketch the plane defined by this equation. So this is what we just talked about. We have the equation 2x plus 3y minus z. I'm actually going to bring this 4 over. Minus 4 equals 0. Okay, so this is how we write the equation of the plane in Cartesian form, the Cartesian equation. So all we want to do is find the x-intercept where we sub 0 and 0 in for y and z. Okay, so let's go ahead and do that. So we have 2x plus 3, 0 minus 4. Okay, those just go away. We have 2x equals 4, x equals 2. So our x-intercept is 2, 0, 0. Now, let's find the y-intercept. So this time, we're going to sub in 0, leave the y, and then 0 for the z. 2, 0 plus 3y minus 0. I guess we could just bring over the 4 again. I like to write it in a Cartesian form. So 3y equals 4, y equals 4 over 3. Okay, and do not convert that into a decimal. Now let's find the z-intercept. So it's going to be 0, 0, z. 2, 0 plus 3, 0 minus z minus 4 equals 0. We get z equals -4. Looks good. 0, 0, -4. And now all we have to do is actually plot these 3 points. Okay, so let's go ahead and draw x, y, z. Okay, x intercepts at 2, so let's just plot that and plot 2. Y intercepts at 4 over 3. And then the z is actually going to be down here, -4. So if we were to connect these 3 points, we draw a slice of the plane. We draw this triangle, which is just a piece of the plane. And that's it. Example 7 is a little bit different. So determine 2 direction vectors for these 2 planes. Okay, so let's take plane 1 and let's determine 2 direction vectors for this one. So we only have x and y, so let's go ahead and just solve for the x-intercept. Okay, so we have 3x equals 12 or x equals 4. And all I did is just skip the part where we subbed 0 in for y. Okay, and now let's solve for the y-intercept, which we sub-zero in for x. We get 4y equals 12, so y equals 3. So we have the point 4, 0, 0, and then 0, 3, 0. So one of our direction vectors can be 4 minus 0, 0 minus 3, 0 minus 0, which is just 4, negative 3, 0. So that's one of our direction vectors. Okay, the other thing is because it doesn't have a z component, so it's missing the z, we know that it's parallel to the z-axis. That means that it's going to go vertically up. Okay, and that means that another direction vector that we can have is 0, 0, 1, 1 being that vertical component, that vertical unit vector. Okay, let's do plane 2. Okay, so we have x minus y minus 5z equals 0. So first of all, we know that d equals 0, therefore it goes through the point 0, 0, 0. Okay, we have the x, y, and z, so we can't actually find the x and y and z intercepts. So instead, what we're going to do is we're going to let one of these equal 0. So let's just conveniently say z equals 0. Okay, and so we're going to have x minus y equals 0. This is a line that's going to cut the plane. Okay, so let's just pick convenient values so that x minus y equals 0. I get 1 and 1. So I get 1, 1, 0. This is going to be our second point. Okay, so let's go direction vector, 1, and let's go ahead and subtract these. 1 minus 0, 1 minus 0, 0 minus 0. So we get 1, 1, 0. That's going to be our first direction vector. Now we're going to do the exact same thing, but instead of letting z equal 0, let's let x equal 0. It doesn't even matter though. Okay, x equals 0. So now we have negative y minus 5z equals 0. What two numbers in this equation are convenient enough to equal 0? So let's just think about this. We have the same sign, so we know that we need opposite signs. Okay? So let's do 5 and negative 1. So then we would have negative 5 plus 5 equals 0. Okay, so that one works as well. Okay, this is really, really easy because since we have the origin as one of our points, these points, like every single point, would pretty much be a direction vector. Because if you see this, if we take this point, point 2, so let's just call it B, okay, 0 minus 0, and then we take 5 minus 0, and then negative 1 minus 0, what we're going to do is we're going to end up with a direction vector with the same coordinates as that point. Okay, so there's another direction vector.